Good morning, students. This is Dr. Kasturi from Wales. Today we are going to see the subject software engineering. Let us get into that. Today we are going to see block 3, that is software design. In that software design, we are going to see about UML models, data modeling concepts, class-based modeling. In the last unit, we saw about scenario-based modeling. In that, we use the use case models where we have users, use cases, and association as the basic components. Okay, and then we saw the airline reservation system as a basic example for a simple example for a use case diagram. Now let us get into the topic. Okay, what is the main objective of this unit? This unit describes about the UML model, its importance, and also explains about the data modeling and class-based modeling concepts and also its types. Okay, we can see one by one. We are going into UML models. A UML diagram is based on unified modeling language with the purpose of visually representing a system along with the main actors. Yeah, we have three basic components there: actors, roles, actions, artifacts or classes in order to better understand, alter, maintain or document information about the system. Therefore, here we represent a UML diagram as actors, roles, actions, classes. Okay, basic components as actors, roles, actions, classes. Why do we do this? To get the better understanding, maintaining, altering any models or document information about the system. We use unified modeling language. This is the we are document the design using unified modeling, software design using unified modeling language. Fine. Next comes the activity diagram. What is an activity diagram? It's a most probably an important UML diagram for doing business process modeling. For modeling the business process, we use activity diagrams. In software development, it is generally used to describe the flow of different activities and actions. In business process, we use this modeling for the business processing. In software development, we use this to describe the flow of activities, different activities and action. Flow of activities will be depicting the flow of activities using the activity diagram. Then these can be both sequential and in parallel. The activities, the flow of activities can be sequential and also it can be in parallel. It can be both. The activities can be one by one or parallel. Okay. They describe the objects used, consumed, or produced by an activity and the relationship between the different activities. Okay, what does the object do? It describes about the consumed or produced by an activity and the relationship between the different activities also depicted. All the above are essential in business process modeling. A process is not focused on what is being produced, but rather on a set of activities that lead to one, the other, and how they are interconnected with a clear beginning and end. Process is a sequence of activities, set of activities. It's not focused on what is being produced, but it's a set of activities. Okay. And each and every activities are interconnected with the beginning and the end. That is a process. Fine. Now, it is going to see a simple example for a, okay, UML diagram. Set of activity diagram. Here we are going to see, okay, publishing process. Okay. Here we have author. This is a work of author and this is a work of editor and this is a work of publisher. This is a simple example for activity diagram. Okay. Okay, what is the scenario here? The above example depicts a set of activities that take place in a content publishing process. What are the activities that will be having in the content publishing process? Okay, that is going to be the activity diagram here. In a business environment, it is also referred as business process mapping or business process modeling. What are the main three actors here? Okay, what are the actors here? Who are all the actors here? Author, editor, and publisher. Here in this diagram, we have three actors. Okay, in this diagram, we have three actors. Okay, the main actors are author, editor, and the publisher. In the diagram, we can see how the diamond shape is used to describe the process that require branching or repetitive process. Okay, the diamond shape, see here, the diamond shape used here is for branching or looping. Okay, here yes or no, or sometimes it is used for looping also. The diamond shape is used for that. And then one of the loops happens when the reviewer is reviewing the draft and decides that some changes need to be done. Yes, looping is what that action is done once again. Whenever the reviewer is reviewing the content and he or she want to do some changes, need some changes in the decide for some changes, it is once again given back to the author, concerned person, so that he will do some modification and give it back to the reviewer. So it is a repeated process so that it is in the loop. Okay. The author then revises the draft and pushes it down the pipeline again for the review to analyze. Okay. Now we can go to the diagram. The author is writing a post. He is the author of the content. Okay. And then revising a draft. Okay. Author writing a post and then the revising a draft. The author is revising a draft and then that draft is posted by the author. Therefore, writing with then he is doing some revision in the post and then he is posting the draft. Okay. And then it comes, what happens, ma? It comes to the editor. Then what is the work of the editor? You should review the draft. That is the work of the editor. Yeah. The editor is reviewing the draft. If it is no revision, no problem, the content is posted. Okay. Otherwise, if some any changes to be done, what happens? It is once again the need revision, once again sent back to the author for revising that. The author is writing the post, no problem, he is posting it. There is any revision need by the editor who is once again revising the draft and then posting. Okay, after that, this draft is reviewed by the editor. If there is no revision, no problem, that post is revised draft is posted here. Otherwise, needs revision when goes back to the author. There is therefore no changes. What happens? Revised, no changes. The revised draft was posted. After that, it should send to the publisher. This is the first activity. Second activity by editor. Third one is by the publisher. Now the content is sent to the publisher. What does the publisher do? He also review the final draft because he's going to publish it as a content. Okay. Therefore, he should review the final draft. There is no changes. Therefore, no problem. That content is published. Okay, the post is published. Otherwise, what happens? He is requesting for change to the editor. Now, editor is what he is doing? He is doing some revisions. Once again, after that, what he does, after doing some final revision, he is giving back to the publisher. It is the final review done by him. If there is no revision, the content is published. This is the starting of the activity, and this is the ending of the activity. This is a good example for activity diagram. Okay. What happened? The same thing. Once again, we are going to see here. There is a set of activities that takes place in the content publishing process. Yeah. And then who are the main actors here? They are the author, editor, and the publisher, or the three actors here. Okay. And in diagram, what we can see, the diamond shape is used to describe what? The processes that require branching or looping. If condition, if it's no problem, goes to the publishing. Otherwise, goes to the review of the editor. That is branching, looping, given back to the editor. Therefore, it is looping. Okay. In this example, one of the loop happens when the reviewer is reviewing the draft and decides that some changes need to be done. Okay. The author, what happened? The author then revises the draft and pushes down to the pipeline. It will be going from one activity to the other activity till the end of the publishing the post. Okay, fine. Now moving on to the next slide. What are the important types of UML modeling? Okay, what is that? Structural modeling, behavioral modeling, architectural modeling. Okay. And then what are structural modeling? There are three types of UML modeling here. What are structural modeling? Captures the static features of a system. Okay, what is the work of the structural modeling? Means it will find or captures the static features of a system. And what the structural modeling should contain or consist of? It should consist of class diagram, okay, object diagram, deployment diagram, package diagram. Okay, class diagram consists of what? What is the name of the class? Okay, what are going to be the objects and the data type? And what is the object diagram? It contains the name of the object and what are the characters and behaviors of the object. It contains that. Class diagram contains the name of the class and types of objects. Object diagram contains what? Name of the object, what functionality it possesses, and what characteristics. That is, characteristics will be maintained as an attributes or variables. Functionality will be behaviors will be known as functionalities. Okay. Deployment diagrams, okay, at the final stage. And then package diagram. What are the packages used? Composite structure diagram and component diagram as a whole. Okay. Okay. Structural model. Okay, it comprises of what? Static features of a system. Okay, represents a framework for the system, and this framework is a place where all the components exist. What are the components we are using? Hence, the class diagram, component diagram, and deployment diagram are parts of the structural modeling. Well, others also, but major parts we can tell as class diagram, component diagram, and deployment diagrams. They all represent the elements and the mechanism to assemble them. The structural model never describes the dynamic behavior because it contains only what? Static behavior. Okay, structural model never describes the dynamic behavior of the system. Class diagram is most widely used structural diagram. What does a class diagram depicts? Name of the class. Okay, objects. Okay, and then what are the behaviors of the object and what are the characteristics of the object. A class diagram possesses that. Class name, behaviors, and then characteristics of the objects. Okay. Okay. What are data objects? A data object is a representation of composite information that must be understood by software. Data object represents composite information. Okay, data object can be external entity. For example, anything that produces or consumed information, a thing, a report, or a display, an occurrence, a telephone call, maybe also a data object, an event, an alarming, a clicking, a telephone call occurrence, event, any event, alarming, an event, okay, physical event, okay, report or a display as a thing, produced or consumed information, a role, salesperson, manager, auditor, an organizational unit or can also be a data object, department, accounts department, production department, sales department, like we say, place can also be data, warehouse. Okay. A structure, a file. Okay. Therefore, these are the examples for data object. It can be any external entity. Okay. And then we are moving on to, it's a continuation. A data object encapsulates data only. There is no reference within a data object. For example, a person or a car can be viewed as a data object. Yes, in the sense that either can be defined in terms of set of attributes. Definitely, if you tell a person as an object, okay, a data object, a person possesses what characters? Person possesses what behaviors? Character in the sense attributes or variables. Behavior in the sense, okay, functionalities. For person will be the object, name, age, sex, qualification, everything will be the characters or variables. Okay, working, designation, everything comes under the behaviors. Okay, fine. If, for example, if we take a student as a object, what happens? Student ID, name, age, sex, everything will comes under the data object attributes, and result, placement, everything comes under the functionality of a student. Fine. Okay. Um, the description of the data object incorporates the data object and all of its attributes. How can we describe a data object? For example, how can we describe a student? By his properties, by his name, by his class, by his behaviors, by his marks, everything. Therefore, data attributes define the properties of the data object, take one or three different characteristics. His placement status, every attributes define a student. Okay. Name of an instance, describe the instance, make reference to another instance in another table. In addition, one or more of attributes must be defined as an identifier, where the identifier attributes become a key attributes when you want to find an instance of the data objects. Yes. For example, if I have a object called student, and I can have the attributes as SID, S name, and then SH, SID, S name, SH, and then so on. For which will be the unique one? Mine, the student ID will be unique. Name can be same. Date of birth also can be same, but student ID or registration number will be unique. Therefore, for every data object, there should be a key attribute that uniquely identify a particular data object. For example, if we take a student as a data object, student registration number, student ID is a what? It is a key attribute of the object student. Fine. The values of the identifier must be unique, although this is not a requirement, but it should be unique so that we can easily identify it. The set of attributes that is appropriate for a given data object is determined through an understanding of the problem context. Yes, through the attributes, we can understand the data object so that we can also understand the problem context easily. Fine. And then moving on to the next slide. The attributes for car might serve well for an application that would be used by a Department of Motor Vehicles, but these attributes will be used for an automatic company that needs manufacturing control software. Therefore, the attributes of car is used for motor vehicles, but those attributes of car are useless for manufacturing controls of automatic company. Therefore, vehicle company it is used. Therefore, to reduce the redundancy and to provide what is redundancy? This duplication or repetition. Unwantedly, we are repeating the same value. And to provide consistency in table, these data object tables are formalized by applying a set of normalization rules that will result in a relational model. Okay. Then what is a normalization? You're storing every data in a table format. Therefore, there are certain norms to be followed to store in the table format, so as to reduce the redundancy, so as to maintain the consistency, so that we can access the data faster. Okay. A given instance of data objects has one and only value for each objects. Yeah. Attribute represent elementary data item. They should contain no internal structure. Given instance of data has one and only value for, yeah. For example, S1.SID is 101. Same way, S2.SID is 102. Therefore, each and every object has a unique value and only one value for each attribute. Fine. When more than one attribute is used to identify data objects, be sure that a descriptive and referential attributes represent characteristics of the entire objects and not a characteristics of something that would be identified, only part of the identifier. Therefore, avoid using more than one attribute for one attribute to identify a data object. Okay, otherwise you can combine and use. For example, I'm having a table like student, I'm having only a person, okay, person name, date of birth, okay. Likewise, suppose I cannot identify a unique key attribute, I can combine what? Person name and the person date of birth. Okay. We think that the name and date of birth, two person will not have the same name and same date of birth. But actually, we should have a unique key like that number. If we're not having, we can do with combining the keys like person name and person date of birth. All non-identified attributes must represent some characters of the instance named by the identifier of data objects and describe some other attribute that is not an identifier. Yeah. For example, if I have a table called student, the identifier key attribute will be SID, and other things I'll be having S name, S age, S class, S result like that. Therefore, other attributes also reveal some information. Yeah, and then we can retrieve information based upon the student ID. I can retrieve information. I want the information of student S1. Then I can get the information by using the key attribute. Okay, relationships. Data objects are connected to one another in different ways. Consider the two data objects, person and car. These objects can be represented using simple notation. Yeah. What is the simple notation? Person and car are two objects. The basic connection between a person, between data object, person, car. And what's the relationship? Ma? Person owns a car. In turn, car is insured to drive. Okay. The connection is established between person and car because the two objects are related. For example, a person owns a car. A person is insured to drive a car. In turn, the car is insured. Okay, who will drive the car? The person. Therefore, a person owns a car and a person is insured to drive a car. This relationship, own and insured to drive, define the relevant connections between person and car. It provides important information about the directionality of the relationship. Yeah, see here. Which direction? Person to car. So car to person. Yeah. Person is owning the car. Car is insured to drive by the person. Therefore, it provides important information about the directionality of the relationship and often reduce ambiguity and misinterpretation. Fine. Okay. Moving on to the next slide, class-based model. Okay. The last topic we saw the data objects. Now we are seeing class-based model. Okay. Class-based modeling identifies classes, attributes, and relationship that the system will use. Yeah, what are the classes? Attributes. What are the classes? For example, I'm having classes called student, classes called subjects, class, student, subject, department, like that. In that classes, I will be having some attributes. What are the attributes of students? What are the attributes of subject? Subject ID, subject name, student ID, student name, and then department ID, department name. Likewise, I'll be having the attributes and the relationship that the system will use. The particular system, what is the relationship? One student studies many subject, and these subjects belong to this department. Likewise, relationship also defined here. In the airline application example, the traveler and the user, the boarding pass represent classes. Yeah, fine. Okay. The airline application example we saw in the last unit. Okay, the traveler or user is an actor. Okay, and the boarding pass. Okay, these are also called as classes in class-based model. In use case model, we define them as actor, as traveler as actor, and boarding pass as a use case. Here, we will identify both the traveler and the boarding pass as a classes. The traveler's first and last name and travel document type represent attributes, characteristics that describe the traveler class. Yeah, what is the how if I'm telling traveler as a class, and what are the attributes of traveler? Name, age, sex, and the document type, everything. And what are the characteristics of the traveler? Which class he or she has been selected for traveling? Traveler class. Okay. The relationship between traveler and boarding pass classes is that the traveler must enter these details into the application in order to get the boarding pass. and that the boarding pass contains the information along with other details like flight departure, gate number, seat number, etc. Okay, this is the relationship between the traveler and the boarding pass classes. Okay, next one is what class-based modeling represents the object, the system manipulates the operations. The elements of the class-based model consist. What are the elements of the class-based model? Definitely classes, objects, attributes, operations. Class responsibility, collaborator models. Okay, what are the elements? Class and objects, okay, attributes, and operations are called as functions or behaviors. Attributes are characteristics. Class responsibility collaborator models. Okay, fine. Classes. Okay, maybe either noun or noun class in the simple table. Classes are found in the following forms. Okay, how many? What are the various forms a class can be found at the various form? External entities, be a people, or the device generated information used by computer based system can be a class. Okay, things, reports, student report, some displays, letters, signal, everything becomes the class. Occurrence, event, yeah, alarm events, clicking event, closing the window of a form, everything comes a occurrence or events. It also a class. Roles, yeah, manager, engineer, supervisor, auditor, accountant, student, user. Okay, whoever interact with the system are roles. Organizational unit, the division, company, zone, division, team are suitable for an application. These are all can come under the classes. Various forms of classes. Okay. And not only this one, see here, here various forms as external entities, people and device generated a computer-based system information, things, reports, displays, signals, events like what alarming events, robot movements, completion of series, a property transferring, debiting, crediting, everything comes under classes. And then roles, manager, engineer, salesperson, and then organizational units can also be have a division. Suppose I take a class as division, division ID, division name, division place. Likewise, I can have. Okay. And next, following these places, yes, name of some place also we can have as a class name. Manufacturing floor or loading dock from the context of the problem. Places can also be as a class name. Structures, sensors, computers are defined a class of object and a class of structures. Okay, sensors also you can tell as a class name. Attributes. Attributes data objects that are defining a complete class within the context of a problem. For example, employee is a class and consists of what are the attributes of employee? Name, ID, department, designation, what is the post is person, salary of the employee, etc. Now, what are operations? Okay, the operations define the behavior of an object. What is the behavior of an object defined? For example, yes, when the previous example we saw traveler, traveler ID, traveler name, and then traveler class we saw it as an operation. It's a behavior. Which class is going on? Okay. The operations are categorized in the following types. Okay, the behavior can be a following type. The operations manipulate the data like adding, modifying, deleting, displaying, likewise manipulating operation. And then operation performs a computation. It processes some computation. And then operation monitors the objects for the occurrence of controlling an event. When it should occur, monitoring the event. Operation behavior, it monitor and act according to that. Whenever I click the close button, what should happen? Whenever I click the submit button, what should happen? It will monitor. Whenever I click the close button, it will go for some other form. Whenever I click the minimize button, it should go for it should minimize. Whenever I click this particular command button, it should open a new form likewise. Okay. When the operations can manipulate data, perform computations, and monitors the objects for the occurrence of controlling an event. It can control events. Okay. And then class responsibility collaborator modeling. What is the class responsibility collaborator modeling? Okay. It provides a simple method for identifying and organizing the classes that are applicable to the system or product requirement. That is what the simple method for identifying, organizing the classes for that are applicable to the system or product requirement. You should identify and organize them into classes. Okay, class is an object-oriented class name. Yeah, it consists of information about subclasses and superclass. Yeah, a class can have a parent class and a child class. Subclass is a child class and a superclass is a parent class. A car can contain what? Superclass, four-wheeler. Okay, if we, for example, okay, um, son, father, okay, and grandfather. For father, class contains grandfather as a parent class and son class as a subclass. Okay, superclass is a parent class and subclass is a child class. So for the consists of all the information. That subclass, superclass is what? So which class it is inherited is what? Superclass. Okay, father is inherited by grandfather. In same way, son is inherited by father and grandfather. Therefore, the class should contain information about the subclasses and the superclasses, child class and the parent classes. Okay. And what are the responsibilities or the attributes and operations that are related to the class? It should be mentioned in CRS modeling. What are the responsibilities, roles, and what are the attributes and operations related to your classes described in the CRS modeling? Collaborations are identified and determined when a class can achieve each responsibility of it. Collaborations are identified and determined when a class can achieve each responsibility of it. If the class cannot identify itself, then it needs to interact with another class. Okay. And as a summary, what we saw here, this unit summarizes UML model, its importance, and also detail about data modeling and class-based modeling concepts and its types. And then as a whole, the questions that can be asked in this unit are: explain UML modeling approach, explain class-based modeling approach, explain data modeling approach in software design, and explain the types of UML modeling. Okay, we have completed the unit software design for UML modeling, its data modeling and class-based modeling types. Okay, thank you, students. Have a nice day. Thank you.